So, after we learned a little bit about hydrogen bonds previously, I want you to go into the properties of water. Water has some tremendous properties, and it's a universal solvent, which means that almost you can try to dissolve many things in water. And we know that across our home and our experiences, the first choice of a solvent that is used to dissolve any substance is usually water. And when a substance does not dissolve in water, then you explore for some other ways of dissolving it. But that's your first choice. And water has this unique feature that it is a polar molecule. Again, polar molecules are molecules that are capable of forming hydrogen bonds. And again, I'm revising this section. We did this before. An electronegative oxygen, which is a stronger oxygen atom, can form weak attraction to the hydrogen of a second molecule. And because of this polar nature, an unequal distribution of electrons, water has a polar nature. The polar property of water also makes it easier for substances to either rise. For example, water will rise to the top of the trees. If you stick in paper in water, you know that it will have a capillary action and it will start going upwards, vertical flow. Adhesion, on the other hand, is a horizontal flow, which means that it sticks with another molecule. High heat capacity is also important, and I'm going to go into each one of them in the next couple of slides. But high heat capacity means that it needs a lot of heat to raise 1 degree temperature rise. Surface tension is a film that is created on the surface of the water, and by through which water ships can float and spiders can crawl in water. And in this image, you can see that solid water which is the ice, is actually shown on the top because it's less than liquid water. So we will explore all these different properties in the upcoming slide. Again, the term polarity will come up over and over again. A polar molecule is one that has a positive and a negative end to it. Other molecules may be defined as either hydrophobic or hydrophilic. Hydrophobic means it's drawing away from water. So if you take oil, for example, and you mix it in water, it does not dissolve because it's hydrophobic. Philic means water loving. So for example, if you take sugar or salt and you dissolve it in water, then it dissolves very well. You have a uniform consistency, and that is called as hydrophilic, which is an end that will get closer towards the water. So here is a large molecule of a lipid in which, notice the term polar head. A polar head would indicate that this region would be able to draw water. However, this region, which is shown on the other side, which is called as a non-polar tail, is hydrophobic, which means it's going to be away from the water. So hydrophilic is your polar head, and the hydrophobic is your water tail, which is repelling from water. Why is water a good solvent? First, before we go on to the term solvent, a solution is a substance in which you have two parts. The first part of the solution is called as a solute. A solute has to dissolve in a solvent. For example, if I take sodium chloride and dissolve salt in a solvent, then this salt is my solute. And the solvent would then be, for example, water would be the solvent. Water is polar, so that's why it's a great solvent. It's a very good solvent for many different reasons. Ionic salt, for example, you can see sodium chloride is dissolving in water. Notice that sodium chloride is made up of sodium and chlorine. And when it splits into two different kinds of ions, which we call as ionization, then each of these ions are surrounded by water molecules, and it it is soluble. Another kind of molecule that is also dissolved in water is called as a polar molecule. An example of polar molecule is, for example, ammonia. This is an example of ammonia, which is your household ammonia, and some of you that use ammonia as a cleansing agent, you can see ammonia dissolves in water. Again, because you can see all these partial negative and positive charges around ammonia, and you can see all the hydrogen bonds that are possible between water molecule and the polar molecule. So any substance, whether it falls into the category A, which is ionic, or whether it's polar, for example, ammonia, these two different kinds of substances can dissolve in water, and that gives a very wide variety of substances. Sugar is also a class B substance over here, which is the polar molecule. The difference between cohesion and adhesion. Cohesion is due to hydrogen bonding. Again, remember, everything has to do with hydrogen bonding for water and lots of its properties. In cohesion, water is going to go in a vertical column. So in the tree, when you're watering the tree and the water goes up, it's because of its cohesive property. Adhesion is because water sticks to each other, so it can go in a lateral movement, so it can go from horizontal way, it can pass water. High heat capacity is another very unique property of water. A calorie is an amount of heat that is required to raise 1 gram of water by 1 degree Celsius. So even if you have to raise 1 degree Celsius of water, a lot of heat is required to be given. And this is very important during summers when the temperature goes very high. Aquatic life can still exist and lives very well, is because water takes a lot of heat from the environment to raise its temperature. So the high heat capacity is beneficial to living cells. Imagine if when you had sudden changes of temperatures and your cells would just evaporate or freeze all the time. And because of this high heat capacity, cells are able to withstand a change in temperature. Hydrogen bond changes when melting and boiling points take place. Without hydrogen, it would melt at minus 100 degrees Celsius, and water would boil at minus 91 degrees Celsius. So you can see how beneficial it is to the environment we live in. High surface temperature. This is my favorite picture in the book in this section. You see this little spider walking on the water, and it's because hydrogen bonds create a sort of film on the surface of the water, and because of this film, little objects can float in water. So if you've ever made some paper ships or paper boats, and you can actually let them float in water, because hydrogen bonds are creating a sort of film on the top of the surface of water, which helps spiders and crawly objects to move across. Water is also more dense than ice, so that's why when temperatures fall, for example in this image over here, you can see as temperatures go down, hydrogen bonds start forming, and the liquid water has changed to ice. But when it does this structure of the ice, notice the way the hydrogen bonds are now creating a lot of space in between. They're giving it a very large structure, so the volume has actually expanded. And you can you've had this experience if you try to fill up a water bottle and leave it in the freezer. If you don't leave any space on the top, you know that it's going to distort the shape of that bottle. So ice will always expand because of the volume that is created by the ice lattice is a lot of empty spaces. And because of this, the density of water liquid water is high and density of ice is low. And when the density is low, ice can float in water. And if the ice is floating in water, you can see in this image over here, if you have an ice layer on the top, aquatic life does not get disruptive, and it actually creates an insulation for the aquatic life during real winter season. And as ice melts in the spring, it draws heat from the environment, which helps to prevent a sudden change in temperature that might be harmful to life. So all of these are very unique properties that allows cellular activities to occur and makes life on Earth possible. Keep in mind, water is present in living cells. Almost 70 to 90% of certain cells are filled with water. The first cell also evolved in water. So because of all these different properties of water, water is an excellent molecule to study.